This lesson is for learning how to draw a Lewis structure. Now, a Lewis structure is the arrangement of the atoms in a covalent bond. Now, we have 6 steps to follow for drawing a Lewis structure. Step 1. Get a covalent formula and draw the electron dot notation for each atom in the formula. So let's look at carbon dioxide, CO2. We're going to draw the electron dot structure for C and O, carbon and oxygen. The electron dot structure comes from the valence electrons, so we need to look on the periodic table. Now, the periodic table shows us how many valence electrons by the group number. Group 1 is 1 valence electron. 2 has 2. 13 has 3. 14 has 4. 15 has 5. 16 has 6. 17 has 7. And then 18 has 8, except for helium, which only has 2 electrons. So here is carbon in group 14, so it has 4 valence electrons, so it's going to get 4 dots. Here's oxygen in group 16, so it has 6 valence electrons, so we're going to put 6 dots around oxygen. So we start at the top, and we put 1 dot on each side before we double up. 1, 2, 3, and 4. That's all there is in the carbon. Now, each oxygen gets 6. 1, 2, 3, and 4, 1 on each side. Now we double up 5 and 6. We'll repeat with the next oxygen. 1, 2, 3, and 4, double up 5 and 6. Step 2 says, from the electron dot notation, determine how many bonds each atom needs to get to an octet. Remember, an octet is 8. So what we're looking at here is how many empty spaces are there around each electron dot notation before you get to 8 dots. Carbon currently has 4 dots, so he has 4 empty spaces. Therefore, carbon will want to make 4 bonds, because each bond fills up 1 empty space. This oxygen has 6 dots, which means it has 2 empty spaces, 1 here and 1 here. So it's going to make 2 bonds. The other oxygen will do the same thing, 2 bonds. Step 3, determine the central atom. We skip this step if we only have 2 atoms. We have 3 atoms. So, we need to determine which one goes in the center. Now, the first rule of thumb is if you have a carbon, you will put that carbon in the center. Now, if there's more than one carbon, like C2H4, you're going to make a chain of carbons in the center, and then everything else goes around it. Now, what if you don't have any carbons? Well, you can eliminate elements from the center. For instance, hydrogen and group 17 elements are never in the center because they don't make more than 1 bond. Now, if you still can't figure out who goes in the center, look at their electronegativity. The one with the lowest electronegativity will usually be the one to go in the center. So for us, in this example, it's quite easy. We have a carbon, so that means carbon is going to be the central atom. So we're going to put a carbon in the center of where our Lewis structure will be. So we're just going to put C for carbon. Step 4. Spread the remaining elements around the central atom and bond each to the center with a single bond. So we have 2 atoms left, 2 oxygens. So when we have 2 of something and something else in the center, we'll just put 1 on each side like this. Now, if we had 3 of something, we could put 1 on each of 3 sides, and if we had 4 of something, we would put 1 on each of the 4 sides. But we only have 2, so we're going to put 1 on each side. And then we're going to put 1 dash in between. Each dash represents 1 bond. Now, a single bond is a single pair of electrons. Step 5. Compare the number of bonds that each element has with the number of bonds each element needed. Add double or triple bonds as needed. So carbon needed 4 bonds. Right now, there's only 2 dashes stuck to carbon, so carbon currently only has 2 bonds. Carbon is not happy. We have to add in some double or triple bonds. Now, this oxygen has 1 dash attached to it, so it only has 1 bond. So it's not happy, so it's going to need a double bond. This oxygen wants 2 bonds as well, and it only has 1, so it's not happy. It will need a double bond as well. We cannot add more atoms than what's in the formula. So in order to satisfy everybody, we have to add double or triple bonds. In this case, we're just going to add a double bond on each side. Now, each oxygen has 2 bonds attached to it. That's what it wanted. Okay, this oxygen, 2 bonds. That's what it wanted. Carbon wanted 4 bonds. We've got 2 on this side and 2 on this side. So we have 4 bonds. Now the carbon is happy. Now you cannot have more dashes next to an element than what you have determined its number of bonds. We could not triple bond an oxygen because oxygen will only make 2 bonds. So you must have 2 dashes stuck to an oxygen. No more, no less. Then step 6 is to add the unshared pairs of electrons. And these only go on elements from groups 15, 16, or 17. So we've got carbon and oxygen here. Carbon is group 14, no unshared electrons. Oxygen, though, group 16. So yes, it will have unshared electrons. So to find out how many unshared electrons, we take the number of valence electrons, we subtract the number of bonds that were made, and that will be our number of unshared electrons. So the oxygen had 6 valence electrons. It made 2 bonds, so 6 minus 2 equals 4. So each oxygen needs 4 unshared electrons. So we are going to put a dot, and a dot. That's 3. It needs 4, so a 4th dot. We'll do the same thing on this side. A dot, and a dot. That's 3, so we double up here for 4. Dots and dashes can never be on the same side. So the unshared electrons of the oxygen must be on the sides that do not have the bonds. So therefore we put 3 on the 3 sides without the bonds, and 1 side gets doubled up. And there's your Lewis structures for carbon dioxide. Now we're going to do a Lewis structure for C2H6. C2H6. Step 1, draw the electron dot notation for each atom in the formula. Carbon, as we know, already has 4 valence electrons. Hydrogen, on the other hand, in group 1, has 1 valence electron. Carbon, 4 dots. There's 2 of them, so we're going to do it twice. 1, 2, 3, and 4. 1, 2, 3, and 4. Now, there are 6 hydrogen. Each one gets 1 dot. 1, 2, 3, 4, 5, 6. Step 2, from the electron dot notation, determine how many bonds each atom needs to get to an octet. So we already know from our last problem that this carbon has 4 bonds and needs 4 bonds. So 4 bonds here and 4 bonds here. Now, hydrogen, on the other hand, has 1 bond. Normally you would say, that takes 7 bonds to get to an octet, so you're going to need 7 bonds. That is not the case. Hydrogen is one of the two exceptions. Hydrogen only needs one more bond to get to 2. So each hydrogen needs one bond. So step 3, determine the central atom. Carbon is always the central atom. If there's more than one carbon, make a chain in the center. So we have 2 carbons. So we're going to put each carbon side by side and make one bond in the middle to make a chain. Step 4, spread the remaining elements around the central atom and bond each to the center with a single bond. So, since we have 1, 2, 3, 4, 5, 6 hydrogens and 2 carbons, we'll give each carbon 3 hydrogens. We'll divide them up equally. And we're going to bond 3 to each carbon. So that way we have 1, 2, 3, 4, 5, 6 hydrogens. Step 5, compare the number of bonds that each element has with the number of bonds each element needed. Add double or triple bonds as needed. So carbon needs 4. This carbon has 1, 2, 3, 4 dashes attached to it. He's good to go. This carbon has 1, 2, 3, 4 dashes attached to it. He's good to go. Each one of these hydrogens only needed 1, and they all have 1. So we do not need any double or triple bonds. Step 6, add unshared electrons to any elements from groups 15, 16, or 17. We already know that carbon is in group 14, so it has no unshared electrons. Hydrogen is in group 1. It has no unshared electrons. So we have a completed Lewis structure that needs no unshared electrons. So we are finished with C2H6.